Encryption didn't fail because of bad code. It failed because physics stopped protecting us. For decades, we believed sovereignty lived inside mathematics, inside algorithms, inside encryption keys so large no machine could break them. But machines did not stay small. They learned, they distributed, they formed fleets. And now the contract between secrecy and surface civilization is breaking. So the next generation of sovereignty isn't moving to space. It's moving down, 36,000 feet down, into the deepest place on Earth. The Mariana Trench is not just deep, it is mechanically hostile. At its lowest point, Challenger Deep, the ocean presses down with over 1,000 atmospheres of pressure. That is more than 1,000 times the weight of the air above you right now. Steel crumples, electronics fail, lubricants collapse, standard robotics implode, satellites cannot see it, GPS cannot penetrate it, and autonomous drone swarms struggle to survive it. For most of human history, the trench was an obstacle. Now, it may become an advantage, because when encryption becomes predictable and when artificial intelligence can simulate every possible key, the only thing left that cannot be brute forced is pressure. On the surface, every secure system lives inside the glass house. Fiber optics route through predictable corridors. Satellites map every heat signature. Cloud infrastructure leaves trails of metadata like footprints in fresh snow. The surface internet is fast, but it is visible. Even quantum research labs rely on environments that can be reached, monitored, or physically infiltrated. But the Hadal zone, the midnight region below 6,000 meters, behaves differently. At those depths, matter is stressed, materials compress, mechanical tolerances narrow. Robotics require exotic reinforcement simply to function. A fleet-learning machine designed to self-repair and coordinate across thousands of units must survive first contact with the environment. And the deep ocean does not negotiate. In this world, sovereignty is no longer about hiding information. It is about placing it somewhere machines cannot comfortably exist. An analog fortress built not from walls, but from physics. There is another advantage hidden in the cold. Modern data centers consume immense energy not just to compute, but to cool. Every processor produces heat. Every cluster demands thermal regulation. Cooling is one of the largest costs of computation, but at the bottom of the ocean, the temperature hovers just above freezing. The environment is a natural heat sink. Microsoft once tested underwater data centers as an experiment. They discovered that sealed oceanic modules ran efficiently, cooled passively by the surrounding water. But what if cooling is only the beginning? What if the ocean is not just a utility, but a jurisdiction? Imagine high-pressure data vaults resting on the seabed, self-contained AI clusters powered by compact energy systems. Heat dissipates silently into currents that already fluctuate. Thermal signatures blend into geological noise. No satellite sees them. No aerial drone approaches them. No surface cable identifies their traffic. In the midnight zone, a server farm does not glow on a map. It becomes indistinguishable from the planet itself. This is the heat sink paradox. The deeper the system, the harder it is to trace. The colder the water, the hotter the computation. And somewhere between those extremes, a new economy forms. But infrastructure does not stay empty for long. If sovereignty moves underwater, eventually people follow. The first underwater habitats were built for research, short stays, scientific curiosity. But technology evolves. Pressurized living pods, reinforced composite spheres, autonomous life support systems. Imagine a network of submerged habitats connected not by fiber optics, but by acoustic relays. Individuals who choose to detach from the surface subscription model. No biometric tracking grids, no predictive advertising layers, no algorithmic reputation scores. They become the unsubscribed. Their circadian rhythms adjust to artificial cycles. Their communication shifts from radio to vibration. Their economies operate on systems invisible to the glass house. Biological detachment becomes cultural detachment. The surface continues trading invisibility. Below, opacity becomes the new currency. Sound travels farther underwater than light. Whales communicate across thousands of miles using low-frequency pulses. Submarines navigate through acoustic signatures. The ocean is not silent. It is saturated with vibration. Now imagine encoding data into that vibration, not through traditional radio, but through patterned acoustic waves. Hydrophones receiving signals masked inside tectonic noise. Data packets disguised as geological whispers. On the surface, surveillance depends on optical signals and electromagnetic detection. Underwater, light fades quickly, but sound persists. An acoustic network does not require satellites. It requires timing, pressure, and patience. This is acoustic encryption, communication that rides inside the planet's own resonance. To intercept it, you would have to physically enter the environment. And to enter the environment, you must survive it. The fortress is not digital, it is environmental. The midnight economy does not announce itself. It does not launch rockets. It does not host conferences. It forms quietly. A trench state here, a pressure vault there, a habitat pod anchored in darkness. At first, they store data. Then they train models. Then they negotiate trade. Computational resources exchanged beyond surface oversight. When the glass house becomes too transparent, some will seek shadow. And the deepest shadow on Earth is not in a cave. It is beneath 7 miles of water, but there is a cost. Pressure isolates. Distance distorts. The further sovereignty moves from the surface, the harder it becomes to regulate. Who governs a server farm no satellite can detect? Who audits a colony that communicates through tectonic vibrations? Who enforces law in an environment physically inaccessible to most of humanity? The ocean has always been a frontier, but this frontier is not about exploration. It is about insulation. For centuries, power centralized upward, in towers, in satellites, in orbital networks. Now it may decentralize downward, into places we once believed unusable. The silent frontier was never space. It was the part of Earth we never industrialized. We mapped it, we measured it, but we did not inhabit it because it was difficult, because it was crushing, because it resisted us. Now resistance is the appeal. The same pressure that once destroyed our machines may soon protect them. The same darkness that once hid monsters may soon hide data. And the same cold that once ended expeditions may soon cool the most advanced AI systems ever built. We thought sovereignty belonged to code. Then we thought it belonged to orbit. But sovereignty may ultimately belong to environment, to those who understand not just encryption, but geology, not just networks, but pressure, not just surveillance, but physics. If surface encryption becomes a broken contract, the next contract may be written in depth, in cold, in silence, 36,000 feet below the noise. The midnight economy does not replace the surface. It shadows it. And in that shadow, a question forms. If privacy can only survive where machines cannot comfortably go, how far are we willing to descend? Because this might not be a matter of if, but when.